everyone, welcome back to my channel Monica Math Classes. Today we will finish the part 2 of quadratic equation. In this part, you're going to understand how to find out the roots of the equation, and also you're going to understand what is the nature of the roots which you have calculated, whether they are real or not. So you're going to decide on the few things, and also you're going to check how you're going to find out the ways to calculate the roots. So first way we are going to understand, and that is by our factorization. Okay, so let's get started. And before that, enjoy your learning journey. So the first thing in this is how to find the solution of quadratic equation, and that is by factorization. Okay, so the first very important part to understand is what are the zeros of the polynomial or the roots. Both are same. They are not different. They both are same. Do you remember, before I begin with this, if I ask you to calculate the zeros of the polynomial, what you have done in that case? You have replaced x by some value of that x, and that x makes that makes x, and when you solve it, it makes equal to the right hand side. That means that's the zero of the polynomial. Okay, so suppose in this I have this particular equation. Now if I want to replace x, suppose by value of the variable, in case I take it as 1, so what happens? So when I replace x by 1, then in this case it becomes, let's see what it becomes, 2 minus 3 plus 1. So I'm taking left hand side. Okay, so you can write that before and just specify what you are taking. So 2 minus 3 is minus 1 plus 1, which is 0. And this is equal to right hand side. Your 0 is right hand side. So understand, this is 1, okay, is the 0 of the polynomial. Okay, and polynomial which is given, and also it is the root of the equation. Okay, both means same. It is same. Okay, so understand again, this is the same thing. Okay, this is the repeated thing from your chapter 2. When you replace x by any value, okay, of this variable x, and it makes equal to right hand side, that means that's the zero of the polynomial or root of the equation. So every time we are not going to check that what makes it zero, what makes it equal to something, whatever value is given on the right hand side, but we will understand by factorization. Do you remember middle term splitting? I hope you remember that you all have done a good practice in grade 8. So middle term splitting. So as the name suggests, we have to split this 5x minus 5x. How? So you have to check in this way. What is the coefficient of x squared? This is 2 and number constant is 3. So multiply both. What do you get when you multiply the coefficient of x squared and this constant, which is equal to 6? Okay, so when you got this as 6, so you have to split this 6 in such a way that the product is 6 and addition should be minus 5. So if I take minus 6 into 1, I get, okay, minus 1 into minus 6, I got 6. And if I take minus 6 and plus of minus 1, I'm not getting this minus 5. So I'm deciding I will not take this part at all. So let's take another one. You have another factor. Okay, so if I say 2 and 3, which makes 6, and if I take minus 2 and minus 3, that also makes minus 5. So this is better for me, where the product is 6. And when I add these 2 and 3, okay, then it gives me minus 5. So I'll take this. So what I'm going to write, 2x squared minus 2x minus 3x plus 3 is equal to 0. Okay, so I have split this 5x as 2 and 3, minus 2x and minus 3. I can write like this. Now you have to regroup your terms. So first and second. So let's regroup this first one. So 2x squared minus 2x. So first, what is common from the first two? 2 and as well as x. So take x minus 1. And from minus 3x plus 3, what is common? I think it's minus 3 which is common. So x minus 1. An important part is middle term splitting is that when you regroup it and when you group them again, x minus 1 with the first and second bracket, it should be same. So your first is x minus 1 and second is 2x minus 3, which is equal to 0. Okay, so these are the two factors you got, x minus 1 and 2x minus 3 is equal to 0. What does it mean? This means that either x minus 1 is equal to 0 or 2x minus 3 is equal to 0. So what if I take x minus 1 as 0? So the value for x is 1. And if I take or 2x minus 3 is equal to 0, then 2x is equal to 3 will go to the other side, become plus. So it become x is equal to 3 by 2. So that means there are two zeros or there are two roots of this equation. So the value for x could be 1 and 3 by 2. So these are the roots of the equation. Okay. So 1 and 3 by 2 are the roots of equation. Understand one more thing, very important over here is if you have quadratic equation, so the roots will be 2. Okay. And if you have linear, it will be 1. So here you will get two roots of the equation. And how do you prove it? How do you justify what you have calculated is right or not? There is one way. You can put the value for x as 1, okay, in this equation. You will get equal to right-hand side, which is 0. Okay. And the second, again, you can check with 3 by 2. When you put x as 3 by 2, again, you will get as 0. So that means both of them are the roots of the equation, or they are the zeros of this equation, or they are the solutions of the equation. So there are many ways, but do not get confused when it comes. I hope it is clear, but it only comes with the practice. Okay, middle term splitting. And it is one of the easiest ways. So when you can do middle term splitting, do that. It's much more easier. Let's move on to and see the next part. Suppose you have another example. You have to find out the root of this equation, 6x squared minus x minus 2 is equal to 0. So if I have to write here this, let me rewrite this, x squared minus 2 is equal to 0. How do I split this? 6 times 2. Again, I told you that before x squared, okay, this is the coefficient 6, which should be multiplied with 2, which becomes 12. How do I split this 12 so that I get here as 1 when I add and multiply, I got this. So let me say, I think we have 3 times 4, which makes 12. This is one of the factors. And if I have 3 minus 4, that also makes minus 1. I think this suits best. Okay, because I should get minus 1 here. So I'm going to split this like 6x squared minus 4x plus 3x minus 2 is equal to 0. See, minus 4 plus 3 gives me minus 1. That's perfectly correct. Now, again, you need to regroup this. So from first two, what is common between 6 and 4? First, I see the numbers. I think it's 2 and the next square and x, minimum common is x. Now what will come inside the bracket? 3x minus 2. Now for the second one, there's nothing common. So that's 1. So now you have 3x minus 2 is equal to 0. So the first bracket is 3x minus 2 and the second one is 2x plus 1. Again, you got two factors, yeah? So what if first 3x minus 2 is equal to 0, that means what is the value for x in this case? It is 2 upon 3. And what if you take 2x plus 1 is equal to 0? Then in that case, you get x is minus 1 upon 2. And answer is 2 by 3 and minus 1 by 2 are the roots of equation, this particular equation. I hope this is clear. So that's how you get practice of it. And my middle term splitting is really nice and fun to do it once you have understood. So these are the two. So let's see another example, one more. When you have something in square root, how do you split that? Because earlier those looks really very small. Now see the next one. So let me rewrite this, 3x squared minus 2 root 6x plus 2. So we are doing actually the first part of this part 2, where we have to calculate the roots of the equation. So this is how. You will see 3 examples solved by me and practice further. So now, if I check, it is 3 times 2, which is 6. Now, how do I split this so that I get 2 root 6? Okay. So for this, understand, I want 6. Do you remember that root 6 into root 6 is also 6? So all the things will be in use. You should not forget whatever you are learning. It is going to use in many topics. So this is, you understand, square root. This is third form. So when you multiply these two, it becomes 6. When you multiply 2, it becomes root 2 into root 2. Understand? Why I'm saying it? Because there's a square root. And so when I add these two, it becomes 2 root 6, which I needed. So now I'm going to split 3x square minus, because it's in minus, so minus root 6x minus root 6x, which will become on addition minus 2 plus 2 is equal to 0. Now, what is common? Okay, so the common part, let me say, as I told you, that 2 can be written as root 2 into root 2. So 3 can be written as, as root 3 into root 3. So what is common between both? At least root 3, because root 6 can be written as root 3 into root 2. Yeah. And there is x. So that means 1 root 3 is outside. 1, 3, root 3 will come inside. Okay. And minus root 2, because root 3 is out. Now, what is common between both? Again, you can write this as root 2 into root 2, and you can write this as root 3 into root 2. So what is common between both? Minus root 2. So what will come? Root 3x minus root 2. Okay. So again, you will find root 3x minus root 2 and root 3x minus root 2. Both the brackets looks exactly the same. Don't you think so? Yes, it is exactly the same. They're equal roots, huh? So that means you will find that both of them are equal roots, repeated roots. So it is equal to 0. So the value for x will be root 2 upon root 3. And these are equal and repeated roots, okay? So you will write here, this root is repeated twice. They're equal roots, right? They're repeated twice, you can see it. So one for each repeated root, okay, root 3x minus root 2. So the roots are, if somebody have to write, what are the roots? So we'll write root 2 upon 3. Or you can write like this also, root 2 upon root 3. Both are correct, okay? So the roots are, both of them are correct. Or, comma, root 2 upon root 3. Or you can write as, just remove this or, we will add this or later. Okay, both are correct. This is our answer. I hope this is clear now. I have taken with one square root as well with the third form. Okay, so now let's see something else. You have understood how to find the nature of how to find the roots of the equation. Now we are going to find out the nature of roots, because here you have seen the two roots are coming as equal. That means this is one of the nature. So the nature of roots decides on one thing, and this is the equation. So let me first of all again re-emphasize on this. The equation ax square plus bx plus c is equal to 0. That is a standard form. Okay, always we have to compare any equation with this. Then x is equal to minus b, you have to remember it. I can't help it. You have to remember. So x is equal to, how I remember, I tell you, x is equal to minus b plus minus square root of d upon 2a. Now, what is this d? D is called as discriminant, okay? Discriminant. You have to remember it. How do you get d? D is equal to b square minus 4ac. And that's why I replace this with b square minus 4ac. So x is equal to minus b plus minus square root b square minus 4ac upon 2a. Now, where you have to use this formula? when you have to factorize and you think you are finding difficulty in using middle term splitting, in that case, you use this, okay? Both the ways you use factorization by middle term splitting and by this way, you will get the same answer. But sometimes what happens, middle term splitting, when you get, simple and easy equation, it's easy. But sometimes you get equations you don't know if I can do middle term splitting or not. Then in that case, you can use this. And sometimes there are equations when middle term splitting is not possible. Okay, it's not that all the equations can be middle term splitted. No. Okay, so you use all the time this, and every time your answer will come remain same. So you have to remember it. Minus b plus minus square root b square minus 4ac upon 2a. This b square minus 4ac is the discriminant. And this discriminant is a deciding factor of our nature of roots, whether our roots will be real or not. Okay, so do you see this plus minus? Okay, so when you see this plus minus, it means that, let me highlight this in. So when you use this plus minus, it means that there are two roots. One is positive and one is negative. Okay. So here you have one with the positive and one with the negative. Okay. So let's see further. So when b square minus 4ac is equal to 0, okay. So in that case, you always get a repeated or equal roots. Like in this case, the one example which I've solved just before this, nature of roots. So in that case, you will get minus b upon 2a. You have to remember it. And the roots of the equation are both minus b upon 2a. You put the value, get the answer. So discriminant d is b square minus 4ac, which I already said. Now, if your quadratic equation is this, and you want to know that if my roots are real or not, so if you have to calculate only this thing first, okay, b square minus 4ac. If b square minus 4ac is greater than 0, that means you get two distinct real roots. Okay, two distinct, I hope you understand, real roots. So real means it could be plus, minus, with root, everything. All are those real numbers. Okay, and distinct means different. Two equal when b square minus 4ac is equal to 0, completely 0. Okay, so you get two equal roots. And when b square minus 4ac is less than 0, less than 0 means you got answer in minus, then means there are no real roots. They are imaginary. There are no real roots. So there are three things you have to remember. Discriminant. You have to calculate discriminant to understand first. So if you have two b square minus 4ac is greater than 0, that means you have two distinct real roots. When you have b square minus 4ac which is equal to 0, that means you have two equal repeated roots, two equal real roots. And when if b square minus 4ac is less than 0, that means there are no real roots. Okay. So let's calculate one of those questions where you have to find out the discriminant. Okay. So let's get started. So first, one of the equation we have 2x square minus 4x plus 3 is equal to 0. Now, first thing, you have to write your standard quadratic equation. Okay. So A is equal to 2, B is equal to minus 4, and C is equal to 3. So all the time you have to compare. Okay. So when you compare, then only you can write your discriminant. What is discriminant? It is B square minus 4AC. Now what is B? It is minus 4. Minus A is how much? 2. And C is 3. So what it minus 4 square means? Minus 4 into minus 4, which is 16. Now 4 to the 8. 8 times 3, 24. Now tell me what answer you got. You got minus 8. Is D greater than 0? Less than 0? What it is? It is less than 0. So What is the nature of root? No real roots. Okay. I hope again I'm repeating. Okay. So 2x square minus 4x plus 3 equal to 0. So you have to compare with the standard, okay, equation, which is ax square plus bx plus c is equal to 0. A is 2, b is minus 4, c is 3, b square minus 4ac. So b is how much? 2. Oh, which is minus 4, which is correct. So 4 square, which is 16, minus 4ac, which is correct. So it is minus 8, which is, there are no real roots. Okay. Now let's see the another example and find out if their roots are real or not. So 3x squared minus 2x plus 1 upon 3 is equal to 0. I have to compare this with our standard equation, which is a is equal to 3, b is equal to minus 2, and c is equal to 1 upon 3. I hope this is clear. Now, what is our discriminant? So when you do, 2, 3 times, you'll remember discriminant is b square minus 4ac. It's not so difficult also. Everybody does that. So b is minus 2 whole square minus 4, a is 3 into c is 1 upon 3. So this 3 and 3 cancels out. So you have 4 minus 4, which is equal to 0. Now, what does it mean? When d is equal to 0, what does it mean? It has, this equation has two equal real roots. Okay? It means this, that it has two equal real roots. Now, what are the real roots then? In that case, when you have, again, I'll take you back and show you. So when it has, okay, two equal roots, then it is minus b upon 2a. So we have to use this minus b upon 2a. So we have to calculate two equal real roots, that is minus b upon 2a. Now tell me what is minus b? Minus b is minus 2. Okay, so minus 2 upon 2a. A is how much? 3, which is equal to how much? 2 upon 6, which is equal to 1 by 3. So my answer is, also find them if they're real. Yes, answer is 1 by 3 and 1 by 3. They are the roots of this equation. They are real. I hope this is clear. So this is one of the very important part which you have done. Once you've understood, practice the exercises and you'll be through with it. Okay. So I hope you have enjoyed today's class, and please go through this video again if you want to understand something about the nature of roots and how to find the roots of equation. So practice, practice, and practice, because practice makes the man perfect and permanent in the learning. So happy learning and keep practicing. Bye then, all of you, rise and shine. Okay, bye.